The diagram shows the curve with the given parametric equations. Parameter is t. The curve crosses the y-axis at the point A and the x-axis at the point B. Part A, we need to show that dy dx is 6 over 2t plus 3. To find dy dx, we need to differentiate y with respect to t and to differentiate x with respect to t. To find dy dt, we need to apply the quotient rule. So we hold the denominator 2t plus 3, differentiate the numerator, minus, now we hold the numerator and differentiate the denominator, all over the square of the denominator. Simplifying the numerator by expanding and collecting like terms. 4t plus 6 minus 4t plus 6 is what we have for the numerator. And that is 12 over 2t plus 3 squared for dy dt. For dx dt, we differentiate ln of 2t plus 3 with respect to t. We need to apply the chain rule. When we differentiate ln of a function, we have 1 over 2t plus 3. And then to differentiate the inner function, we just differentiate 2t plus 3 with respect to t. And that gives us a 2. And we have 2 over 2t plus 3 for dx dt. dy dx is given by dy dt over dx dt. So dy dt is 12 over 2t plus 3 squared. And we divide all this by 2 over 2t plus 3. When we divide by a rational term, we change it to multiplication, flip the second term, we have 2t plus 3 over 2. And then we can cancel the 12 and the 2 cancels to be a 6 and a 1. 2t plus 3 and the square, we can cancel that as well. So that dy dx is 6 over 2t plus 3. That is what we need to show. Yeah, we don't need that bracket here. Part B, we need to find the gradient of the curve at A, meaning that we need to find the value of dy dx at A. dy dx is in terms of t, so we need to find the value of t at A. At A is on the y-axis. X must be 0. So when x is 0, x is actually ln of 2t plus 3 is equals 0. Now we can convert this into exponential form so that 2t plus 3 is e to the 0 and e to the 0 is 1. Where 2t plus 3 equals 1. So that 2t is 1 minus 3, which is negative 2, and t is negative 1. We now find dy dx at the value where t is negative 1, and we have 6 over 2 times negative 1 plus 3, so that will give us 6 over negative 2 plus 3, which is 6 over 1, and we have a value of 6 here. For part C, find the gradient of the curve at B. At B is the x-intercept. On the x-axis, y is 0. 2t minus 3 over 2t plus 3 is y. If this is 0, when you cross multiply this, we have 2t minus 3 equals 0. Or another way to look at it is, if the ratio of two terms is 0, the numerator must be 0. So that 2t is 3 and t is 3 over 2. And we find the value of dy dx when t is 3 over 2. We have 6 divided by 2, 3 over 2 plus 3. So we have 6 that cancel. Then you have 3 plus 3 here. And that gives us a value of 1.